Okay, anytime you add the first in terms of an infinite sequence, okay, infinite means it goes from 1 all the way to infinity, right? And we talked about partial sums before. This is called an nth partial sum. An nth partial sum. Well, the nth partial sum of an infinite sequence can be found by using the same formula we just used. All right, if you're trying to find a partial sum, that's okay. We want to find your 50th partial sum for example 6 of the given sequence, -6 to -2 to 2 to 6. So we're going to say we need to find S sub 50. All right, we need to find S sub 50. So that means your n is 50 over 2 times your first term plus your last term. So your first term is -6 plus your last term, which is we don't know.
You're gonna have to use.
Oh, we don't know. A sub 50. So what you're going to do is you're actually going to have to use your other equation that we just used previously, not in example 5, but in example 4. You have to use your other example to find your other equation to find out what A sub 50 is. So you actually need to find, you have to use A sub n equals A sub 1 plus n minus 1 times d to find A sub 50. All right, so if we want to find A sub 50, that means we have A sub 50 is equal to your A sub 1, which is, what's your first term? -6 plus n. How many terms are you looking for? What's your n value? 50 minus 1 times your common difference. Yeah, your difference in the given sequence is, you're adding 4 every time, aren't you? So we're going to put a 4 right here. So what you can do is you can simplify all this, and to just make your life a little bit easier, you actually get 190. You should get 190. Anybody get 190? I hope?
Yeah.
Good deal. So then to find your sum, now can we plug this into our original formula we were trying to use? So 50 over 2 is just 25. And you go from -6 plus your 50th term is 190. I definitely would not want to count that up that many times. So you get a final solution of, what do you get when you add all those terms together? 4,600. Also known as 46 hundo. Ta-da!